And we are recording. Okay, so y'all, when we were here on Thursday, we talked a little bit about permutations. In a permutation, y'all, the order is important. When we select three people to be president, vice president, treasurer, that means the first person automatically goes to the president position. The second person automatically goes to the vice president position. The third person automatically goes to the treasurer position. So the order in which they appear is important because they're going to be for those specific positions. Now, in the combination, y'all, a combination, the order is not important. So if you think about a combination, a real easy combination to think of is in the morning. If you go to Stripes and you ask them, can I get a taco of bacon and egg? And they're trying to be funny with you, say, I'm sorry, all I have is egg and bacon. It's the same thing, right? That's what a combination is. Doesn't matter the order. It's the same thing, right? Okay, so combinations, y'all, there is a formula. I'm going to show you how to use that formula. We're going to do a lot of this stuff on the calculator, y'all. Like I said, remember, when we're using our calculator, whatever comes out, y'all, we take that as the word of God, as a palabra de Dios. So just we want to be real careful when we're doing combinations, okay? So in a combination formula, y'all, or combination setup, this is what combinations look like, okay? And again, combination, the order is not important. So let's take a look at the first problem that I have right here, and we'll set up this combination problem. So it says, look, a class has 32 students. And how many different ways can 6 students form a group for an activity? So y'all, if there's 6 of us and there's going to be in a group, it doesn't matter who's the first one in the group, who's the second in the group. We're all in the same group together, okay? So y'all, what we're doing here is we're choosing. So I'm using the word choose because I'm going to be using combinations. So how many people are in the class? 32. So y'all, we're going to go 32 and we're going to choose. How many people are we going to choose to form our group? 6. So y'all, let me show you how we're going to do this on our calculator, okay? Y'all, I'm going to grab my calculator right here, right? Same one I've been using. Let me turn it on. Let me clear everything out. Y'all, I'm going to do the same thing. I'm going to go 32. Then I'm going to hit my math button. And I'm going to go to that PRB. Remember, y'all, you can either go to the right 4 times, or if you were right here, you can go to the left once. And then we're going to go to choose. Y'all, choose is the third one. So I'm going to hit number 3, or you can just go down to the third one. And we're going to choose. We said 6. And what I'm coming up with here, y'all, is 906,192. 906,192. And that's how many different ways we can choose 6 people. Yes, I'm going to show you again. So look, y'all, first thing we're going to do, we're going to clear this out. Okay, so the first number I'm going to hit is 32. Okay, then I'm going to hit my math button, and I'm going to go over here to where it says PRB. So you can do it 2 ways. You can either go to the left once here, or you can go to the right 3 times. And then hit the number 3. If anybody has their mic on, y'all, turn it off because it's doing the little echo. And then hit number 6. And then hit enter, and there's our 906, 192. Got it? Awesome. Very good. Okay, so look, y'all, we're going to try another problem similar, again, where we're doing these combinations. Okay, so y'all, I'm going to scroll down a little bit further, and it says an environmental agency is analyzing water samples from 77 lakes for pollution. 5 of those lakes have dangerously high levels of dioxin. 6 lakes are randomly selected from the sample. Using technology, how many ways could 1 polluted lake and 5 non-polluted lakes be chosen? Okay, so look, y'all, this is a little bit more complex because we have some more parts to it here. Let's do this. Let's figure out what is the total number of lakes that we have. Anybody know what's the total number of lakes? There's 77 of them, okay? Now, y'all, we got 77 lakes. But when I start to read right here, it says, look, 5 of those lakes are basically polluted, right? They have high levels of something in there. So why don't we do it like this? We have 77 lakes. Sorry, trying to get my pen to work here. Let's take a look at the ones that are polluted and the ones that are not polluted. Okay. So how many lakes are actually polluted here, y'all? Do we know? 5. 5 of the lakes are polluted. Y'all, my next question to you, how many lakes are not polluted? Anybody know? If there's 77 lakes total, 72. Everybody agreed it's going to be 72 because there's a total of 77 of them, right? So 5 are polluted, then the rest are not, right? At least not with that particular business, whatever they have. Okay, so now, y'all, let's take a look at how many lakes we're going to pick or we're going to choose. We're going to choose 6 lakes, right? We're going to choose 6 lakes. Now, I'm going to start reading a little bit further. It says, how many ways could we choose one of them that's polluted and 5 that are not polluted? Okay, so out of those 6, y'all, we want to have one of them that's polluted and we want to have 5 that are not. Okay, so if we want to have one that's polluted, y'all, how many polluted lakes can we choose from? How many polluted lakes are there total? 5. So we're going to say out of those 5 polluted lakes, we're going to choose one of them. Okay. Now, how many lakes are not polluted? 72, right? Out of the 72 lakes that are not polluted, how many are we going to choose from those? 5. Does that make sense how we're setting this up? So we know we have a total of 77 lakes. 5 of them are polluted, 72 are not. Now, what we want to say is, how many ways can we pick one of those 5 that are polluted and 5 that are not polluted? So we are choosing 1, I'm sorry, from that group of 5, and then we're choosing the other 5 from that group of 72. Okay. So y'all, again, what I'm going to do here, just the way I wrote it out, y'all, with parentheses and everything, I'm going to type that exactly on my calculator. Okay. So let me clear this guy out. I'm going to go parentheses. I'm going to say, what's 5? We're going to go to math. We're going to get to our PRB. We're going to do the choose, which is number 3. We're going to choose one of those. And then I'm going to open up, you can put a times if you want to, you don't have to, but then I'm going to open up a new set of parentheses. I'm going to say, look, out of those 72 lakes that are not polluted, I want to again choose. So I'm going to go to my PRB and I'm going to choose how many of those we're going to choose. We're going to choose 5 of those, right? And then we're going to hit enter, and huge number here, y'all. And all I'm going to do is just write this guy down. So 699. 577 20, right? So that looks like 69,957,720. Okay. So y'all, one way that you can kind of verify, like, hey, am I really doing this the right way? One thing we can say is, look, how many lakes did we have total? We had 77 of them, right? And we're going to pick 6 of those lakes. Y'all, if you add 5 and 72, boom, there's your 77. If you add 1 and 5, there's the 6 that we're choosing, okay? But we're choosing 1 from that polluted group and then the 5 from the non-polluted group, okay? All right, my friends, I'm going to keep scrolling down my list. And now we're going to start talking about probabilities, okay? So y'all, when we talk about probabilities, remember, probabilities are always numbers between 0 and 1. So they can be 0, they can be 1, they can be 0.97, they can be 1/3, but numbers between 0 and 1. I should never get a negative probability, and I should never get a probability that's more than 1, okay? And for these problems, y'all, they are going to ask us to use decimals. So all my numbers should be something like 0 point something, okay? So if I end up with 3 point something, I'm off. I made a mistake, okay? For probabilities, always numbers between 0 and 1. All right. So now it says a committee has 9 members. There are 3 members that currently serve as the board's chairman, vice chairman, and treasurer. Okay, each member is equally likely to serve in any of the positions. 3 members are randomly selected and assigned to be the new chairman, vice chairman, and treasurer. What is the probability of randomly selecting the 3 members who currently hold those positions for chairman, vice treasurer, and treasurer, and reassigning them to those same positions. Okay. So we have a committee, right? You are the chairperson, you're the vice chairperson, you're the treasurer, right? This is the order. What's the probability that they get chosen to be those same positions? Now, y'all remember, when we are picking somebody to be in a particular position, the order is important. When the order is important, my friends, we use permutations, okay? So let's think about it this way. How many people are on the committee? 9. And out of those 9 people, we're going to pick how many? 3. So we're going to say 9 permutation 3. Now, y'all, if I said this was the order, 1, 2, 3, the only way that that can happen again is that same order. There's only one way for that to happen again. So, y'all, what I'm going to do is this is how I'm going to do my problem, and I'm going to enter this in my calculator exactly the way I see it. My recommendation, my friends, is anytime you're doing, whether it's combinations or permutations, I would always write this part in parentheses. I think it just makes it a little bit easier. It ensures that I don't make like a computational error, okay? So I'm going to clear my calculator, and I'm going to say 1 divided by parentheses. I'm going to go 9, math. We're going to go to probability. We're going to do the second one because we're picking people. We're picking 3 to be in those same positions. And y'all, it's asking me to round to 4 decimal places. So I want to ask you, if I was going to go to 4 decimal places, 0, 0, what do you think? 1, 9, or should we change that 19 to a 20? To a 20, right? Why? Because this 8 is 5 or more, so it's going to change that 9 into a 10. We got to carry that over. So 0.0020, right? Y'all, with the probability problems, my first number in every one of these, if I'm dealing with a probability, should be a 0 point something, okay? Because it's probability. Okay. Now, let's take a look at the next question here. Again, I'm still looking for probability here, y'all. So I already know, look, my answer is going to be 0 point something, okay? It says a warehouse employs 22 workers on the first shift. So it's 22 people on shift 1. There's 19 people on shift 2. And there's 10 people on the third shift, okay? And I'm going to kind of get right that here. 8 workers are chosen, okay, at random to be interviewed about the work environment. Find the probability of choosing exactly 5 first shift workers. Okay, so let's think about it this way, y'all. First question, do we know the total number of workers? Well, we have 22 for shift 1. We have 19 for shift 2, and we have 10 for shift 3. What's the total number of employees or workers or whatever you want to call it that we have? Anybody know how we would figure that out? What do you think we'd have to do, y'all? Add them up, right? Let's do it. Let's Adam and Eve, right? So we got 22 plus 19 plus 10. Y'all, we got a total of 51 workers, okay? All right. Now, oops, sorry. How many workers are they going to choose out of those 51? 8. Okay, so y'all, it's usually easier for me to do my denominator first. We have a total of 51 employees. We're going to choose 8 of them, okay? Now, the question says, find the probability of choosing exactly 5 people that work on the first shift. So y'all, out of the 22 that work on shift 1, we want to choose how many from there? 5, right? So look, y'all, we're going to say out of those 22, we're going to choose 5. But how many workers are we choosing in total? We're choosing in total 8. So do y'all agree we still need to choose another 3? So y'all, those other 3 are going to have to come from this pool. So what's the total number of workers that we have combined from shift 2 and shift 3? how many workers would you have just coming from shift 2 and shift 3? 29, right? And you say, how do you know 29? Because that's how many that's going to give me, right? So 29. And we're going to choose the other 3 from there. Okay. So y'all, again, just like I'm doing before, I'm going to do this on my calculator, y'all. I'm going to give you a suggestion. When you're typing this in, let's put all of this stuff upstairs in parentheses. Okay. So look, let me walk you through the process and how I'm going to do this on my calculator. I'm going to clear this screen out, y'all. And I'm going to do double parentheses because I got 2 sets right here. So double. I'm going to say, look, we're going to go 22. I'm going to go to math. We're going to choose number 3. We're going to choose 5 from there. And then we're going to pick 29. And from there, y'all, we're going to choose, again, another 3. Okay. And I close my parenthesis there, y'all. Okay. And I'm going to close it again. And then I'm going to go divided by, open up my parentheses one more time, 51, y'all, math, probability, and we're going to choose 8 because that's how many we're choosing in total, okay? Y'all, before I do anything else, I want you to notice something here. We're picking 5, or we're choosing 5 from the first shift. That's why we said, look, there's 22, choose 5. But we were choosing 8 in total. That means we still had to choose another 3. Well, if we're picking 5 directly from shift 1, then the other 3 all have to come from shifts 2 and 3. And that's why we said there's 29. Okay. We were choosing 8 people in total from the 51. Y'all, again, just to make sure you're doing this right, if you add 22 and 29, that gives you 51. If you add 8 and 3, that gives you the 8 right there. Okay. Now, let me hit enter here. And look what we said, right? First number's got to be 0. I know it's not there, but it's 0. Y'all, if we go to 4 decimal places again, if we go to 4 decimal places again, what do y'all think? 0.1511 or 0.1512? 0.1511, right? 1511. Excellent. All right, so y'all, I'm going to scroll down a little bit further here in my list. And this problem is similar to the one we just did. We have a shipment of 11 microwave ovens, and out of that shipment of 11, 3 of them are defective. That means 3 of them don't work. A restaurant is going to buy 4 microwaves. What's the probability of them buying at least 3 non-defective units? Okay, so look, y'all, we're going to go really slow here. We have a total of 11 microwaves. Now, out of those 11, y'all, some of them don't work. How many microwaves do not work in this shipment of 11? How many are defective? 3. Okay, so 3 are defective. So y'all, if 3 of them are defective, how many are not defective? Anybody know? So if out of the 11 of them, if 3 of them don't work, how many do work? 8. Very good. 8 non-defective, right? Okay. Y'all, we are looking for probability. We have 11 microwaves, and this restaurant is going to choose 4 of them, okay? So y'all, I've always found it easier if I do my denominator first, okay? Because my denominator kind of gives me the big picture. There's 11 microwaves. The restaurant's going to buy 4 of them. So 11, we're going to choose 4. Now, we want to make sure that we have at least 3 non-defective units. So y'all, if we want to have at least 3, that means 3 of them are not defective and 1 would be defective, or all 4 of them are not defective and we don't have any that are defective, right? So remember what at least 3 means, 3 or more. So what we want, y'all, is we want either 3 or 4 of them coming from that group, okay? Because then we want to make sure that at least 3 of them are not defective. So let's think about it this way. If we were going to pick, say, 3 from this group, Would you guys agree that out of those 8, we're going to choose 3 of them? But y'all, remember how many microwaves we're buying in total? We're buying how many in total? 4. So y'all, if we pick 3 out of this group, would you all agree that we would have to pick 1 out of that group? Or we would have another possibility, y'all. We could pick all 4 from this group. So look, I'm going to put plus 8. We could choose all 4 from there. And if we choose all 4 from there, y'all, then that means out of this group, we're going to choose none. Okay. Now, y'all, just like I told you before, I am going to set up some parentheses here to help my process a little bit easier and making sure that when I'm doing this, according to the order of operations, right, that my calculator is doing this the right way. Okay, y'all, before I go in and start to do the actual calculation, let me just do a real quick recap. What does that mean? Remember, we're picking 4, and we want to have at least 3 that are going to be working. So that means out of the 8 that are working, we could have picked 3 of them, which would have meant that we would have picked 1 out of those that don't work. Or over here, we picked all 4 that are working, and we didn't pick a single one out of the ones that didn't work. Okay. Now, again, y'all, I'm going to do this part on my calculator. Let me move this over to the side so everybody can see everything. Okay, let me clear or turn it on first. Sorry, clear my screen. So look, y'all, 2 sets of parentheses. Boom, boom. We're going to go 8, math. We're going to choose 3. Okay. Again, we're going to go 3, math. We're going to choose 1. Okay. And then we have plus. Let's open up parentheses again. We're going to, out of the 8, we're going to choose all 4 from those, which again means that out of the 3 that don't work, we're not going to choose any of those guys. Okay. Double parentheses divided by parentheses again, 11, y'all, math. And we are picking or choosing 4 in total. And I'm going to hit enter. And y'all, again, if we're going to, this one tells me 3 decimal places, y'all. What do you think? 0.721 or 722? 21. Awesome. So 0.721. Okay. And we got it. Okay. Okay, so y'all, let me scroll down because it looks like I think I got one more question here, and then I will start 4.1 with y'all. And let's take a look here. It says a warehouse employs 25 workers on the first shift, 19 workers on the second. It's kind of similar to the problem we did before. 12 workers on the third shift. Okay, 8 workers are chosen at random. So y'all, before I even start reading anything, I'm going to do this. I'm going to go first, second, and third. Okay, just so that I have my numbers. 25 on the first, 19 on the second, 12 on the third. Okay. And what we're going to do, y'all, it's telling me that we're going to choose 8. Okay. Now, let me continue to read right here. Okay. Find the probability of choosing 2 second shift workers. Okay, so we're going to choose 2 from the second shift and choosing 2 from the third shift. Okay. So, y'all, let's do what we did earlier. Let's first figure out what is the total number of employees. So I'm going to take 25 plus 19 plus 12. We have a total of 56. Okay. We have a total of 56 employees. And remember what we're going to do, y'all. We're going to choose 8 of them. My denominator, my friends, for me is always the easier one to set up. Okay. So let's take a look at what we want to do, y'all. We want to choose 2 from the second shift. How many people are on the second shift, y'all? 19, right? So look, out of the second shift, out of those 19, we're going to choose 2 of them, right? Okay. Now, it also says, y'all, we want to choose 2 from the third shift. How many people are working the third shift? 12. So out of those 12, we're going to choose 2 as well. How many people did we say we were going to choose in total? 8. So y'all, the other 4, where would they have to come from? Very good. I heard y'all say it. The other 4, do y'all agree the other 4, y'all, would have to come from the first? Because we want exactly 2 from the second and exactly 2 from the third. But the other 4, the only place they can come from, y'all, is from the first. So look, 25, excuse me, and we're going to write choose 4 again. And again, y'all, just as a quick reminder, I'm going to drop all of that stuff upstairs in parentheses, right? And again, y'all, come back over here. Let me clear my screen, and I'm going to type in really, really slowly, y'all. Again, I think one of the most difficult parts, or not, I shouldn't say difficult, but an easy place to make mistakes is just when you're typing this business in, okay? So what I will tell you is just, be careless, right? And as you're doing this, so that you don't hit the wrong button. Boom, there we go. Divided by, and then we said we had 56, and we were again choosing 8 people. And let's type that in. And y'all, I think this directions here is saying let's go to 3 decimal places. So, sorry. So y'all, 3 decimal places, 0.100 or 0.101? 101, right? Good. 0.101. And we're done. Okay. All right. So, y'all, that was the end of chapter 3. So, where we stopped right there, y'all, that material, I'm going to, hold on real quick. I'm going to stop recording real quick, y'all, for a second, and then I'll come back and I'll record again. So, let's come back here. Let's stop that for a second. Boom.